We know the integral of x to the n dx. We covered that. It's you add 1 to the power and you divide by the new power. And you add c to it. And you can't use that. N cannot be -1. What happens when n is -1? Remember, that's 1 over x. Who has a derivative 1 over x? Isn't that the natural log of x? So when n equals -1, then the answer is this. Nothing new here. So when I said to you, what's the integral of x squared or x cubed plus 5 dx? You go, okay, let's deal with this one. Break it down, the integral of x cubed dx plus the integral of 5 dx. What is the integral of x cubed? X to the 4 over 4. What's the integral of any constant? It's the constant times x plus c, because that's indefinite integral. Nothing new. Now integration by substitution here, that's what the topic. I'm not doing any of that stuff here yet. But here's an example. I want to integrate x plus 4 to the power of 20 dx. Now I got a problem. There's no way on earth, and I'm going to multiply this 20 times.
So like an integration equivalent to the chain rule?
Well, exactly. Very similar to the chain rule. So what I'm going to do here, I'm going to let, I just got to be careful here. I'm going to let u equals what? X plus 4. So what's the derivative of that? What's du dx equal to?
1.
Equals 1, or I can say du equals what? Isn't that equal to dx? Now we can take this problem and let's change it to u. We can say that's the integral. Instead of x plus 4, I'm going to write what? U to the power of 20. And what is dx equal to? Du. You can't integrate when you have u and dx. None of us can. They have to be matching. If this is u, this has to be du. Now I can integrate this, add 1 to the power and divide by the new power. Add 1 to the power, u to the power of what? 21 over 21 plus c. And the last step here, since my problem did not have u in it at the beginning, I need to change it back to x. That's x plus 4 to the power of what? 21. And that's my answer. I didn't have to multiply that 20 times. Let me modify that problem just a little bit. Put a little twitch in it. Instead of x plus 4, how about that was 3x plus 4 to the power, I don't know, of 10. Same thing. Ah, I forgot to take pictures of these before I leave today.
Can't cut the recording in half, can you?
No, but I'll do it after. I like when I just start talking about stuff on video, you know. People on the other end go, what is he talking about? Oh, so you get what you paid for, you know? So again, I'm going to let u equals 3x plus 4. What's the derivative of that? It's called du dx. That's a 3, which means what? Du equals 3 dx. Notice we have a little problem here. So when I go back to that problem, try to plug it in, I go, I got it now. I can write this, the integral of what? U to the 10. But I don't have a 3 here. I only have dx. This one has 3 dx. How about if I divide both sides by 3? What's dx equal to? Isn't that 1/3 du? So now in place of dx, I'm going to write what? 1/3 du. I can take the 1/3 outside. It's a constant. U to the 10 du. 1/3 u to the 10. That becomes what? U to the 11 over 11 plus c. One 33 or u to the 11 over 33 plus c, or the answer is what? 1 over 33. What is u equal to? 3x plus 4 to the power of what? 11 plus c. If I take the derivative of that, I guarantee you we're going to have that answer. And let's see if that's true. I'm making the claim. If I take the derivative of that, it should give me this. Let's check it. What is the derivative? Let's see if that gives me that. There's the 133 in the front. The derivative of this, that's what? The extended power rule. It's 11 times 3x plus 4 to what power? 10 times the derivative what's on the inside. What is the derivative of 3x plus 4? 3. Plus, what's the derivative of any constant? Derivative? 0. I don't know why I put, here we go. I don't know why I put the square bracket there, but 3 times 11 is what? 33 times 1 over 33, they cancel. What's left? 3x plus 4 to what power? 10. Was that this one? Yes, it is. I'll try a couple more examples. Then we can go start the test.
Is it still set up to only have 2 hours once you start?
No, I left it open until midnight. If you think about, if you just look at it, doesn't this looks like the derivative of that? That's when you have more than one thing, you're trying to figure out which one u. I see this looks like the derivative of this, so I'm going to let u equals that.
And you can only do that because the coefficient's the derivative of what's in the parentheses?
I don't care about the 2, because that could have been 5, 7. That doesn't bother me. As long as, because the derivative of this is 2x, so I need an x.
Right.
So that's why this actually I'll let u equals that. That number doesn't have to be the same. You'll see in the next example I'll change it.
Okay.
So if you let u equals x squared plus 1, what's the derivative of that? What's du dx? Isn't that 2x? Which means du equals what? 2x dx. Well, this is perfect. Look at this. Put it with that one. Combine them together. That's equal to what? Du. That is your du right there. So this problem now becomes the integral of u to the 4th, and the 2x and the dx multiplied together, it's equal to du. Again, integrate that, add 1 to the power, divide by the new power, plus c. And you always want to change your answer back to x because the problem did not have u in it. So if I give you that for a homework and you give me this, I'm going to say, what are you talking about? There's no u in the problem. So you got to change it back to x. I might think you're on some kind of illegal substance there. And that'll be the answer to that one. Now, Mitch brought a point, so let me do something to answer his question. Here we go, Mitch. 5x squared x cubed plus 8 to the power of 7 dx. Now, what's the derivative of x cubed?
3x squared.
I don't have 3, I got 5. As long as I get the x squared, I don't worry about the 5. So here we go. Let u equals x cubed plus 8. The derivative of that, du dx, equals what? 3x squared. And du equals 3x squared dx. Notice I don't have that. I got a 5, not a 3. Well, let me take a closer look at that. Let me take the 5 outside and let me reshuffle this. Right? I took the 5 outside. Notice here, this is very similar to that, except I have the extra what? 3. Let me divide this side by 3 and this side by 3. What will happen to these? Gone. So now I can change this problem. There's the 5. U to the 7th times, what's x squared dx equal to? What is x squared dx equal to?
D over 3.
Yep, du over 3. This is a 1/3. So what's 5 times a 1/3? It becomes 5/3. So if the number is the only problem, we can fix that. We can play with the algebra and take care of it. So that's u to the 7th. Now add 1 to the power and divide by the new power. U to the 8 over 8 plus c, which is equal to what? 5 u to the 8 over 24 plus c. And the last step, change the u back to x. So 5, in place of u, it's x cubed plus 8 to the 8th power divided by 24 plus c. Maybe 2 more problems. I'm out of paper, but I have a graph paper. I'll use that. Here's the graph paper. Hopefully the camera is focused. It doesn't get off focus because of the height. What is the integral? Try this one. Of sine to the 5th x cosine x dx. What's the derivative of sine? Nope, derivative of sine. Cosine. So let u equals your sine of x. What's the derivative of that? It's cosine of x. Which means du equals what? Cosine x dx. Now plug it in. Instead of sine of x, we're going to write what? U to the 5th. Instead of cosine of x dx, we're going to write what? Du. What's my answer? U to the 6 over 6 plus c. And u is what? Sine x to the 6th power divided by 6 plus c. One came to my mind. I'll make that maybe my last one with u substitution. I thought about the integral of tangent. Not derivative, the integral of tangent. Tangent is what? Sine over cosine, isn't it? So you can write that sine of x dx over cosine of x if you want to. Now, if you let u equal sine of x, it's not going to work here because the cosine in the bottom. But if I let u equals cosine of x, what's the derivative of cosine? Negative sine of x. So du equals what? Negative sine of x dx. Well, when you look at that, there's no negative in it. See that? You only have sine of x dx, but you don't have a negative. So you can multiply both sides by what? Negative 1. So negative du equals sine of x dx, or negative 1 if you want to. So you can take this problem now and change it to the integral of sine of x dx, that's a negative du over u. You can take the minus outside, 1 over u du. Now let's go back and think. What trig identity has a derivative 1 over u or 1 over x? Natural log. That is the minus sign, the natural log of u plus c. So now, here's the minus sign, that's the natural log. What is u equal to? Cosine of x. So the integral of tangent x is negative the natural log of cosine x.
In the homework, will we have to add the c in there also?
If it's indefinite integral, yes, always. If that was a definite integral, then you plug in your limits, and the c will disappear.